Lesson 3 of the unit quickly reviews drawing a line using slope-intercept from grade 10. Slope-intercept allows you to draw a line basically without making a table of values, just using one point and using slope as a traffic cop idea. So if we can draw lines quickly, it makes grade 11 math a bit more easy to understand. So in example number 1, if I wanted to find one point algebraically and then use the slope, we could go ahead and do that. You only need 2 points to draw a line. And in example number 1, I've asked for a particular point, the y-intercept. Now remember how to find the y-intercept algebraically. To find the y-intercept algebraically, you plug in 0 for x and solve for y. And that is easy to do. You could actually do it in your head, and that's what you get. And again, you probably remember this from last year in grade 10, but again, notice that the y-intercept of 2x plus 3 is equal to 3. And again, what I want you to remember is, hey, there's a 3 right there, and it's no accident. So we could go ahead and plot this point right now, and actually, if you recalled, what slope is, and slope is a traffic cop, you could plot at least one more point and draw the line. But as a further reminder of grade 10, we're just going to play along. We're going to make a table of values, and we're going to plot those points, and we're going to see what they see. So I'm just going to make a few quick points. Again, I've just substituted into the equation, and I've plugged in my x and I figured out my y, and I'm going to go ahead and plot those other points. So we have -5, -7, we have -3, -3, we have 1, 5. Oops. If I plot the first one right, we had 1, 5, and finally we had 3, 9. So there's 5 points. And if I ask you, what do you notice about these 5 points? Well, I hope you notice they line up. And again, we could connect the dots because all those other places in between those dots, like the decimals, we could figure them out if we wanted to, but we won't. But here's a question. If you pick a pair like this, it really doesn't matter which pair you pick, but if I pick that pair, how would you get from one point to the other? So going vertically and horizontally, well, you go up 2 and you go right 1. That's how you could say it. And again, from grade 10, I hope you remember, you always do the vertical first and the horizontal second. And what is that? What does that up 2 right 1 represent? Well, it represents the slope of the line. And in this case, the slope of the line is 2 over 1, or just 2. And from these two little things, I hope you recall that we can identify the slope and the y-intercept of a line if it's written in this form right here. And in this simple example, the 2 in front of the x will represent the slope, and the number after the x will represent the y-intercept. And you probably did a whole bunch of these examples in grade 10, and if you forgot them, just make up a couple of your own y equal -2x minus 7, or y equals 1/2 x plus 5, and find the y-intercept, find the slope, and you will see that this relationship always holds. And this relationship allows us to graph a line really quickly. So again, summarizing what you did in grade 10 then, to graph a line in y equals mx plus b form, all you need to do is plot the y-intercept, use the slope to find another point, and then connect the dots. So let's do these examples really quickly. This one right here, my y-intercept is -1, my slope is 2/3. I plot the -1, I use slope up to right 3, up to right 3, or down to left 3, down to left 3. And I can't use a ruler on here, so but you will. I'm just going to try to draw my best line. And that might be the best line I ever drew by hand. Example number 4 is a little bit trickier because what I want you to notice is it's not in y equals form. And in order to read off the slope and the y-intercept, it has to be in y equals, not this. So we need to isolate y. And again, I have a rule of thumb. If the y stuff is positive, it stays where it is. And if the y stuff is negative, I move it. I'm going to plot my y-intercept. I'm going to plot my slope. So -2/3. I'm going to use the negative to go down, the 3 to go right. Down 2/3. Or we could have went up to left, up to left. So in this one right here, again, you're going to use a ruler. I'm going to try the best I can. To connect those dots. So, a lot better than making a table of values, a lot better than maybe making some bad algebra arithmetic mistakes. Away we go. So the other thing that was important in grade 10 to remember is if you're given a picture, you can go ahead and write the equation of a line. And if you're writing it in mx plus b form, all you really need to do is find the y-intercept and find the slope. So let's have a look at these two, and we'll do these really quickly. So in this one right here, there's my y-intercept. In this one here, there's my y-intercept. In this one right here, I just find two nice points, any two nice points, and I count up vertically and horizontally. So in this example right here, the slope is 1/1, and the y-intercept is 0, -2. And in our equation y equals mx plus b, we could write 1/1x minus 2, and that could be 1x minus 2, or it could just be y equals x minus 2. In our second one, well, we've already found our y-intercept, and in order to go from one point to another, I'm just going to pick this one to this one, two nice points. I'm going to go down 2, and I'm going to go right 1. So my slope is going to be vertical down 2, right 1, -2, and we already know our y-intercept is 0, 3. So in the second one, y is equal to -2/1 x -2/1 x minus 3, or we could write it -2x minus 3. Plus 3, sorry. Plus 3. Okay, so quick and easy, being able to find equation of a line. Sometimes in writing an equation in y equals mx plus b, you're not given the y-intercept right off the bat, and what you have to do is find it. Now, if you're lucky, pictorially you can find it if it's a nice point. If it's not a nice point, we have to rely on algebra. So here's an example where I tell you a point, I tell you the slope, so you have half the information, you already have the slope. But what we want is we want the y-intercept. So a picture is always a good way to attack a problem. So that's what I'm going to do. I'm going to graph 2, 5, and I'm going to use the slope and see if I can find a nice y-intercept. So again, a slope of 4. 4 is a nice number, but 4 is not a nice way of the ratio of vertical to horizontal, which is slope, what slope is. So a slope of 4 is also a slope of 4 over 1. And when we write it as a fraction, it helps us understand the vertical to horizontal. So remember, the top number represents the vertical distance between 2 points. The bottom represents the horizontal distance. So 4 can be represented as up 4, and 1 can be represented as right 1. If I went up and to the right, I'm going away from the y-intercept. So instead of up right, I want to go down left. And I'm still not at the y-intercept, so I'm going to go down left. And when I do that, I actually hit the y-intercept. So pictorially, I know what the answer is. I know the slope is 4 and the y-intercept is -3. But we're going to do it algebraically. And algebraically, always start off with your form of the line, your formula. And in this case right here, I know what m is, so I can make my substitution. And right here, we look like we have a problem because there are 3 letters I don't know, y, x, and b, and one equation and 3 unknowns seems a little bit difficult to figure out. But we do have some x information. It's the x coordinate of this thing right here. And we do have some y information, and it's the y coordinate of that point. And I'll remind you of the equation of line property from grade 10, which says if a coordinate makes an equation work, it's on the line. So we can use that x and y information to figure out b. So I know 2 comma 5 is on the line, so I'm going to make that substitution. And when I do make that substitution and subtract 8 from both sides, I do get my -3 as I wanted. So the equation of the line, when you're not given the y-intercept, you have to do that little bit of algebra. Okay, finally, same idea, last example, but with this one, I just want to remind you of what you might do when you have a fraction. So again, this one, let's see what the picture tells us. -3 comma 9 down 2 over 3. Hey, look at that. We get a really nice y-intercept. We know the answer is 7. So what we want to do is we want to make sure our algebra matches. Always start off with the equation, the form of the line. It helps your brain because then you go, hey, okay, I'm going to plug in this thing. And again, here's an x, here's a y. We're going to substitute those into the correct place. And here's the only thing I would say that is different from the one above. When you're multiplying a fraction and an integer, always make the integer into a fraction. And it's really simple. Put it over 1. When you do this, you remind yourself about your fraction arithmetic multiplication. You multiply across. So in this one right here, we get a negative times a negative is positive. We get 6 over 3. 2 times 3 and 3 times 1 plus b. 6 over 3 is equal to 2. And when we subtract 2 from both sides, there's the 7 as we see in the picture. So the only reason I really did this one was to remind you of that little algebraic good idea. Write an integer as a fraction when you're multiplying 2 fractions together. So here's a quick little summary of how to write the equation of a line when you have 2 pieces of information. It might be 2 points, and then you just count the slope. So it's always slope stuff first, whether it's given or you have to figure it out. Then you plug in the x and y, one of the points. Then you solve for b, and finally plug b back into the original equation.